Hello, and welcome to G Fun Facts Online, where we unpack the biggest and most baffling facts from across the cosmos. We humans love order. We like things to fit into neat boxes and follow predictable rules. And for a long time, the universe seemed to agree. When astronomers looked out at the stars, they saw a kind of cosmic logic. Big stars make big planets. Small stars make small planets. It just makes sense, right? You can only build with the materials you have. But what happens when the universe throws a curveball? What happens when we find something that, by all accounts, should exist? Today, we're talking about the cosmic misfits, the impossible worlds, the giant planets found circling tiny stars, and how they're forcing us to tear up the rulebook on how planets are born. So, how do we think planets are made? For decades, the leading theory has been something called the core accretion model. Picture a brand new star, surrounded by a huge, spinning frisbee of gas and dust, called a protoplanetary disk. In this disk, tiny dust grains start sticking together, like cosmic dust bunnies. They grow into pebbles, then into mountain-sized chunks called planetesimals. These smash together, eventually forming a rocky core. If this core gets big enough, about 10 times the mass of Earth, its gravity becomes so immense that it starts gobbling up all the gas around it, ballooning into a gas giant like our own Jupiter. This is a bottom-up recipe, and it works great for explaining most of the planets we see. The key ingredient is having enough solid material to build that big initial core. And that's why we expected to find giant planets only around large stars with massive, material-rich disks. But recent discoveries have turned this tidy picture on its head. Meet TOI-5205b, nicknamed the Forbidden Planet. This world is the size of Jupiter, but it's orbiting a tiny red dwarf star that is only about 4 times bigger than the planet itself. To put that in perspective, astronomer Shubham Kanodia said that if the Sun is a grapefruit and Jupiter is a pea, this new system is like a pea orbiting a lemon. According to the core accretion model, the disk around this little star should have had nearly enough rocky material to build the core needed to create such a monster planet. This thing is so big that when it passes in front of its star, it blocks a whopping 7% of the star's light, making it a prime target for the James Webb Space Telescope to investigate. And it's not a one-off. There's also LHS 3154b. This planet is about 13 times more massive than Earth, orbiting a star that's only 1/9 the mass of our Sun. It's like finding a professional heavyweight boxer in a kindergarten classroom. The scientists who found it calculated that its star's protoplanetary disk would have needed 10 times more material than theory predicts for such a small star. As co-author Suvroth Mahadevan put it, this discovery really drives home the point of just how little we know about the universe. More recently, astronomers found TOI-6894b, a Saturn-sized planet orbiting the smallest star ever found to host such a large companion. Each one of these discoveries is another nail in the coffin for our simple, comfortable theories. So what gives? How are these impossible worlds forming? Scientists are scrambling for answers, and it's forcing a major rethink. One idea is a tweaked version of the old theory, called pebble accretion. This suggests that instead of building up from large chunks, a planet's core could grow super fast by sweeping up trillions of smaller, pebble-sized objects. This might speed up the process enough for a giant planet to form around a small star before its gas disk disappears. Another possibility is that some other process, like gravitational instability, where a planet forms directly from a collapsing clump of gas, might be able to happen in smaller disks than we thought. Or maybe these disks aren't isolated systems. Perhaps they can pull in more raw material from the surrounding space, like a baker getting an extra delivery of flour halfway through making a cake. This is where the James Webb Space Telescope, or JWST, becomes the ultimate detective. By looking at the starlight that filters through the atmospheres of these strange planets, JWST can read their chemical fingerprints. This can tell us what they're made of and give us huge clues about how they formed. For example, a planet formed by core accretion should be richer in heavy elements than its star, while a planet formed by direct collapse should have a very similar composition to its star. The data from these cosmic misfits, especially from worlds like TOI-6894b, which might have an atmosphere cool enough for us to detect ammonia for the first time, will be revolutionary. The discovery of these giant planets around tiny stars is a powerful reminder that the universe is constantly surprising us. These forbidden worlds aren't just oddities. They are signposts, pointing us toward a new, more complete understanding of how the incredible variety of planets in our galaxy came to be. They show us that our rulebooks are written in pencil, ready to be erased and rewritten. As we continue to point our ever more powerful eyes to the sky, who knows what other impossible things we'll find? Thanks for tuning in to G Fun Facts Online.